A cylindrical object of outer diameter 10 cm, height 20 cm, and density 800 kg per meter cube is supported by a vertical spring and is half dipped in water as shown in figure. First, we have to calculate the elongation in the spring in equilibrium condition. Okay. Now, first of all, let's draw the FBD of the block. Right, Kx upward, Mg downward, and another V rho g upward. Fine. So at equilibrium, I can write Mg is equal to Kx plus V rho g. Now M is the mass. Mass can be written as V of the block, complete block, into rho of block into G, K into X, plus this V is the volume that is dipped inside the water. So it is V by 2 because it is given half is dipped in water. It is given over here, right? So into rho of water into G. So just substitute the values. V total can be written as pi r square h. So it can be written as pi into 0.05 because diameter is 10 centimeter, radius will be 5 centimeter, and in meters it will be 0.05. Pi r square h, height is 20 centimeter, into rho of block is given as 800 into 9.8 is equals to K 500, that is the value of K, into X, that is what I have to calculate, plus V by 2, that is again pi into 0.05 whole square into 0.2 by 2 into rho of water, that is given as 1000, into G. Fine. So you have to solve this complete equation, just the calculation part, and you will get the elongation, that is the value of X, as 0.235 meters or 23.5 centimeters. Right, that's the answer for the first part. In B part, if the object is slightly depressed and released, find the time period of the resulting oscillation of the object. Fine. Now what will happen if I'll push the complete block slightly by a distance of x? This elongation is my mean equilibrium position. Okay, the net force on this position is 0, so this is my equilibrium condition. Now let's say if I suppress the block by a distance capital X downward, then and resulting a restoring force will start acting on it. The magnitude of the restoring force will be equal to Kx, because this is the additional spring force that is applied to bring the block back to its equilibrium position. Fine. Plus V rho g, and the volume will be just pi r square x, capital X rho g, because this is the extra restoring buoyant force that will act to keep the block in the equilibrium position, equals to Kx plus F restoring. So this restoring force can be written as mass into acceleration. So mass into acceleration is equals to K into capital X plus pi r square capital X into rho of water, of course, into G. So acceleration can be written as K plus pi r square into rho of water into G divided by M. This is my X. Fine. So I can write this complete coefficient, the coefficient of X can be equated to omega square, because that is what the condition of oscillation is. So omega comes out to be under root of K plus pi r square rho of water into G by M. So the time period will be equal to 2 pi times of M divided by K plus pi r square rho of water into G. Now just substitute the values. 2 into 3.14. Right, the mass can be calculated by volume, that is pi into 0.05 whole square into 0.20 whole square into 800, this is the mass, divided by 500 plus 3.14 into R is again 0.05 whole square rho of water into 10. So the time period comes out to be 0.93 seconds. That is the answer.